Hello everyone, this is problem 60 permutation sequence from Leetcode. It is a Leetcode hard problem. We are given a set of numbers 1 to n and we are also given k. We need to return the k permutation sequence. For example, these are the all the permutations for 3. So and for if k is equal to 3 we need to return 2, 1, 3 and so on. So how to deal with such questions? So what is a permutation? So we'll first see some background about it. So we are given 1 to n numbers, right? So how many total ways are possible? Total n factorial ways are possible to arrange these numbers. So let's see what we have if we place 1 at the starting. If we place 1 at the starting, we have n minus 1 places, right? So this n minus 1 places can be arranged in n minus 1 factorial way. So if we place 1 here, then we have n minus 1 factorial permutations with 1 on its 0th index. Now if we place two numbers here, so now we have n minus 2 places, right? So now we can form n minus 2 factorial permutations, right? So this is the idea behind the question. So now we are given k. Okay, so we'll take a example 4 and 9, right? So we are given 1 2 3 4 and k is equals to 9. So how do we find the permutation? So like if we place 1 here, so how many permutations we get? We get n minus 1 factorial, which is 3 factorial. We get 6 permutations with 1 on it, but our k is greater than 6, right? So we move on to the next number, we go on 2. Now we get another 3 factorial, we get 6. So now it's 12. So our k is less than 12. So we know that 2 is we know that k is greater than 6 but less than 12. So 2 must be on its first index. So we have first index as 2. Now like we know that it's not first, so we can subtract 6 from 9. So we have 3 remaining, right? 3 number of moves we can say. So we have 3 left. Now we got 2 here. Now we have 3, k is equal to 3 for this permutation. Now how can we, now we have available numbers as 1 to 4 because 1 3 4, 2 is used, right? So now if we place 1 here, so if we place 1 here, so how many choices we got? 2 choices. So this can be filled in 2 factorial ways, which is 2, but our k is 3. So we need to change number. Now the next number is 3, so we put here 3, and now how many choices we got? 2 factorial, we got 2 choices. Now k is greater than 2 but less than 4, right? So 3 must be at this position. So we got 2, we got 3, and further we got only one move, right? Okay, let me explain it now. We got 1 and 4 are the possible solutions. Now we need to place them. So how can we do this? Now if we place 1 here, then we got 1 factor. Okay, so now we place 3, so we can subtract 3 minus 2. Now we have 1. So for this permutation we have k is equals to 1. Now in one, if we place 1 here, 1 factorial numbers can be made, and we have exactly that. So 1 must be here and the remaining 4 must be here. So this is how we are going to fill this position. So let me discuss how can we do this. So to write this in code, the idea is we get all the numbers up to n, right? So what we do is we get an k. So initially let's say our index is 0, right? So we are checking for 1. So okay, or while k is greater than 0, right? So what we can do is our index is 1, id is 0, right? So if we take 0, how many places can we fill? We can fill exactly n, or we can take a uh, index 0 I also. So for the first index, like these are 4 index for 4 digit number, so we can take for generalized way it is n minus 1 factorial, right? For 1 we got this many, for 2 we got this many if we place them at the first position. Now this is some value v. So when we say that specifically 2 is here or 3 is here, when our k is less than the number of permutations generated by it, so we can write a while loop. While k is greater than while k is greater than v, we can simply pass on this, like we had initially k is equal to 9, so we had 6, then it was greater than 1, so we moved on to this. So now k is equals to 3. What we did was just 9 minus 6, right? now we moved on to 2. Now 2 gives us 6, but our k is less than 6, so we knew that 2 was at that first position, right? So similarly, while k is greater than v, we can keep subtracting v from it, and we increase our id, right? So this will ensure that we end up at the correct index, and after this we can take a string, which will be our answer. We can append this, uh, we can take a list or array something, and we can uh, store this number. So after we use one, we can delete the used one. So we can add the number at the id index, and we keep moving. And if in between we get, if our k becomes 0, we can break. So now there may be a possibility that k will be finished before completing all the indexes. So after that, whatever order is left in the array, we can as it is append to the string. So after that, we can directly append those characters to the string. So how to code this? So we this is our answer string. We take a list and we add all the numbers to it. We take an index id, and I've run a for loop. So what will this do is, I made a factorial function, and int value will tell me the factorial of n minus I minus 1. So while k is greater than val, I kept subtracting k, I increased id. But now if rk is less than or equal to val, we can add that index, we can add that element at id index, and we remove the used number from the list, and we can set a index to 0. After that, we can add the remaining unused numbers as it is in the sorted order, and we can return this. Let's try submitting.